Hi friends, let's build a multimodal RAG system using knowledge base which contains text as well as images. First, let's thank Thomas for this nice image on his Medium post. Now, let's say we have some blog posts or Wikipedia articles which contains the text as well as images. So in step 1, when we prepare our knowledge base, we extract all the text as well as the images. Now, for our regular RAG system, we take all these documents, we chunk them, we create embeddings, we put them in the vector store. We do similar things for these images. So for each image, we create embedding and we put them in the vector store. So that's how we build our multimodal RAG system. Now, when the user asks a question, we create embeddings for that question. This time, instead of searching for similar vectors, only from this vector index, which is based on text, we also search for images which are semantically similar to our user question. Okay, so we extract images and we extract text as context. And to the generator LLM, we provide both text and images as a context. So this LLM can use both sets of information to synthesize an answer to the user. Okay, so that's what we are going to build in this video. All right. So here we have an helper function. What we are going to do is we are going to download some Wikipedia articles on this Tesla, Porsche and Polestar cars, and we process the pages to extract text and images. Okay, so the focus is not how to prepare the data. You might already have a knowledge base which already contain both the text as well as images. So you might as well start from here. Okay, but for the demonstration purpose, we are using these Wikipedia articles. Okay, this code is simple to understand, but in case if you do not understand anything, please let me know in the comments. All right, so we are downloading these 3 Wikipedia articles. We are processing the pages, and the text we are saving as txt files, and we are looking if these articles have any images, JPEG, PNG and SVG. If they have, we are storing them as the files, JPG files. Okay, now after we run the code, this is how it looks like. So here we have 3 text files, one for each car, and then from those 3 Wikipedia articles, we have downloaded the images. Okay, now as I said, you might already have a knowledge base which contains some text documents, PDFs, etc. along with the images. Okay, all right, so for the demo purpose, we just downloaded this. All right, but that's not the focus. Now let's see how we can build this multimodal RAG system. All right, so the important ones are, we are going to need this multimodal vector store, and we are going to create a multimodal query engine. Okay, now for the vector store, we are using this quadrant vector store, but any vector store works fine, because the images, we are creating the embeddings and storing them in the vector store, right? It's just like how we do for the text. So as far as the vector store is concerned, images and text doesn't make any difference. We are storing only the embeddings. So any vector store would work. Now we will be reading the data from the directory. So that's why we need this simple directory reader. Yeah, and the prompt template, which you must have used quite a few times by now. All right, so first we create this quadrant client, and we are going to create two vector stores, one for the text, one for the images. Okay, so here we call this text store. We give it a name, some text collection, which is going to contain our text chunk embeddings. And similarly, we create another store. We call it this image store. All right, these two vector stores, we combine them here using this storage context. Okay. All right, and then we read our documents from this folder. So this is the folder where we saved our data, right? The images as well as the text. All right. Now, once we read the documents, using the metadata, I'm just printing the file type to make sure it contains this multimodal data. So as you can see, we have a number of images and we also have these text files. Okay. All right. Now all the magic happens here. All we need to do is just build this multimodal vector index, which in turn is two separate vector indexes, one for images and one for the text. So it will go through all the documents, and depending on the document type, if it is image or if it is text, it create those embeddings and put them in the appropriate vector store. Okay, so here we have provided that storage context which contains both the vector stores. All right, so we build the index, and then we will be creating a query engine, right? Exactly similar to a normal RAG system. So for this, for the generator or the synthesizer, we are going to use the GPT-4 multimodal. Obviously, we need multimodal because this LLM going to have both the text and images as the context. So this LLM should be able to understand both images and text. Okay, we need a multimodal model. All right. Yeah, so this is a standard prompt template, just saying, hey, you will be provided some context below and use only that context, not any prior knowledge to answer the question. Okay, so we created the template, and using the index along with this multimodal LLM, we have created this query engine. Okay, so once we have the engine, we can start asking the questions. It's a two basic question, but again, the purpose of this demo is how to build, right? All right, so we are simply asking a very basic question. Tell me more about Porsche. Okay, tell me about Porsche. We don't have a previous question to say more about, but let's say that's what our question is. And we simply invoke the query engine. And here we got some response, pretty standard. Talks about this Porsche Taycan car. Okay, talks about battery, so on and so forth. But the interesting part for us is what was provided as context to the LLM. We wanted to see that there is text as well as images provided to this LLM when synthesizing this response. Okay, all right. So the response metadata contains what has been provided to the LLM as context. So let's use that metadata to see what text as well as what images have been provided or retrieved from the vector index. Now here we have another helper function. All it does is simply plot images. Okay, just again some helper ones. Here what we are doing is, so from the response metadata, as you know, it contains two types of nodes, right? One is text nodes, the other one is image nodes. So from the metadata, we are accessing the text nodes, and then we are displaying such nodes information, right? So the node ID and the similarity. So these are the text nodes. For example, this is the actual content of that chunk. Okay. Now, since we set the length to 200, it's cut off here. But this is the first text document retrieved by our multimodal vector store. Okay. And similarly, this is the second document. And then here we are using the image nodes from the metadata, and we are passing that information to this plot function, which simply plot those images. Okay. So as you can see here we have these two Porsche cars. Okay. So when the user asked this question, the embeddings have been created, and the question embeddings have been compared for semantic similarity in this image index to retrieve relevant images. Similarly, in this text index to retrieve semantically similar text. Okay. So for that question, we have extracted two text chunks and two images, and we have provided these four pieces of information to the LLM, to the multimodal LLM, and based on all that information, here is the response synthesized. Okay. So it's quite straightforward. It's pretty much like a normal RAG system. All we need is a multimodal LLM, and we need to create two vector stores, one for each mode, and then we combine those vector stores using the storage context. And in the standard way, we use this multimodal vector index to create the index, and then the query engine. Now, it don't have to be just two indexes. We might even have audio files or video files, etc. So we can have multiple indexes as well, as long as we have a multimodal LLM which can understand all those modes of data. Okay. That's all for this video. Yeah, do let me know if you have any questions or comments. Thank you very much.